So the closest point on spline is searching the closest point on a spline. So it's pretty simple. So you can use those three here just inside nodes, not inside the object manager. So let's to explain the closest point on spline, let's go to the example scenes. And then there is an example scene called closest point on spline example basic. Let's open this one. Hide the information here. And then here is the asset capsule here. And here inside the asset capsule, we have here our closest point on spline asset. So when you drag it in here, you can see it's the same here. So, and you can see it has as input a query position. We feed in here the position of our null object. So this is the null object here. And then we have the geometry, so the spline geometry. So I have here these 4 circles as spline geometry. And then as outputs, we have the closest point, the distance, and the segment ID. So let me show, let's hide this and this. So the red ball here is the closest point. So when I move the ball around here, you can see we have always the closest point on a spline, depending here on our null. Then we have another output. This is the distance to the closest point and the segment ID of our splines. So you can see when we move the null around, we have different outputs here. And there are 2 other examples here inside the example scenes where you can dive in and see some playful experiments that I made here with the closest point on spline. So this like this abstract orb here, you can always jump into the capsule and see how everything works. And it is connected with the gradient intersection asset from my library. And then there is a second one that is pretty similar, where we have those intersections here with the closest point on spline. Also here you can jump into the nodes capsule here and see how everything is built. And then of course also press play. And yes, that's it for the closest point on spline. Let's jump to the next one. So the field vertex map allows you to bring in field data into scene nodes. So let's make a little example. I already have here a nodes mesh. Let's open this one, bring in the field vertex map. Maybe let's hide the asset browser, bring this down here. It's a little bit bigger. Then let's bring in a sphere. Let's add the sphere here to the field vertex map and then output here the geometry. Then maybe add some additional segments. Make it icosahedron. Let's have a look here. And then let's go to the field vertex map. And inside inputs, then of course, first you have the name of the vertex map. So you can see you have here already the vertex map. And then you have the field object. So which field we like to bring in. So let's start with a linear field. And we have here a linear field. Then you have to bring in the linear field. And then you have to define the type. So here are all the types that are working. So there are not all the fields, but the regular ones. And then let's check the vertex map. And you can see we have now the linear field here inside of nodes. And then you have here also a range mapper. So you can clip here the fall off here if you like. And then of course you can play around here with the linear field. And when you like to switch the field here, so maybe you like to have a cylindrical field here, then you have to go to the field vertex map again. Then switch here the type also, say cylindrical. Let's make this a little bit smaller, and you can see now we have here the cylindrical field here on our sphere. And there is also a little example scene. So let's go to the example scenes. Open here the field vertex map example 1. And here you can see the different fields are operating on those planes here. So here are all the fields that work. So you can open it here. And here you see you have the different field vertex maps that correspond here one of those 4 fields here. So we can play around here and see how they are working here. So that's it for the field vertex map. Let's move to the next one. The light vertex map builds a light map and a shadow map. So we have here a scene with a floor here and with this head, and a null here as light source. So with the Z direction pointing to the tip of the pyramid here. So let's bring in here the light vertex map as child of the connect object. Then we need a light object. So let's bring in here our null. And now we can see we have here a light map. So here this side is in shadow and this side is in the light. So, and we have also a shadow map here where it paints the shadow here to the floor. And because it's now switched to directional light type, we can rotate here our little light and we can see the shadow moves from back to front. And of course we can also say here the light type is a point light. So now we can move here our light around and now it acts like a point light. And then here are the names. So the export names for our 2 maps here, and then the maximum distance for our shadow map. And when you go to the example scenes, we have here the light vertex map example 1. Here you can see we have here an additional vertex map where I mixed the shadow map and the light map together and added a texture. So we have this result here. Also in the first part of my paint stroke tutorial, there you see another use case for the light vertex map where I used the light vertex map to paint my paint stroke. So if you're interested, go and have a look into this tutorial. So that's it for this one. Let's go to the next one. So with the plane collision, you can check if a vector is colliding with an infinite plane. So I have here already a plane. So this is our plane, the visualization of our infinite plane. Then we have here the point A and point B and an object group. So let's open the object group. Then let's bring in here our plane collision asset, maybe hide this one here. You can see here we need a point A, a point B, then the plane position and the plane normals. So let's bring in here our point A and B. Let's use the translation here of point A, then also point B. Then we need the plane position and the plane normal. So here's our plane. Let's use the plane position here, so the translation. And we like to collide in the Y direction. So we need the normal here, this Y direction. You can do this by splitting the matrix here. So there is a command called matrix to vectors. So then add in here our global matrix. Then you have vector 1, 2, 3 and offset. And the vector 2 is our Y direction. So our Y normal. Then add this one here to the plane normal. Then we have here the it checks here if there is a collision between those 2 points, and then the hit position. So let's check this by adding a sphere to our hit position. Let's search for a sphere. Then switch the sphere to a nodes operator. Then add the hit position here to the translation, and then the sphere here to the output. Oops, here to the output. Make it smaller, maybe 10. Then let's check if everything worked. So you can see when we move here our point A around, or point B, we see where the collision between these two vectors is. So we can check this also with a tracer. Let's add a tracer here, and inside of the tracer add A and B. Then let's connect all objects here, and we can see the connection, the collision is here between point A and B is directly here, and also you can move the plane here. So you can see we have here a plane collision defined by point A and B, and here our plane. So the plane split modifier is pretty straightforward. So it does what it says. It splits the mesh along a plane. So I have here this elephant here. Let's bring in here the plane split. Add this here, then move the modifier so it cuts along the modifier axis. So we can rotate this around, and you will see it cuts now along the y-axis. So then on the settings, you can define which axis you want to cut. So in the x-axis, for example, or the y-axis or the z-axis, of course. And then which output do you like to have? You like to have just the top, you like to have the bottom, or do you like to have both sides? And then we have also here the selections that are that get stored here. So when we go here to both, and let's use again our selection visualizers. Let's go to models, Druckli models, bring in a point visualizer and a polygon selection visualizer. Then here inside the polygon visualizer, bring in here our elephant, and go and select search stored selections. Then you can see you have here the back selection and the front selection. So these are those two polygon selections. And then of course for the points, let's bring in here the elephant. Let's select search stored selections. And you can see here, we have here the edge selection.